99% of all species that have ever lived were wiped out in a series of global disasters that nearly pushed life to the brink of extinction. But without these events, we wouldn't be here today. Right after Earth was born, a violent event in the solar system changed it forever. Two planets collided in the cold void of space, and one of them was Earth. The impact almost destroyed our planet, but instead turned it into a home. Our planet is about 4.5 billion years old. Over this time, Earth has experienced one disaster after another. It's hard to grasp the vast timescales that shaped our planet. To put it in perspective, imagine Earth's violent history as one full day. The clock starts at midnight, and the first catastrophe is just minutes away. At that point, our solar system was still forming, and 20 young planets were orbiting the sun, with Earth being one of them. Earth's surface was a hellish landscape, with no water or oxygen, and it was covered in toxic volcanic gases. Just before Earth had a chance to settle down, it collided with another young planet. The collision was so massive that it nearly destroyed Earth. But instead, it set off a chain of events that led to the birth of life. Without this disaster, no life, including us, would have existed. But how do we know this happened? And how did this collision set the stage for life to evolve? Astronomer Bill Hartman has spent his life studying the early solar system. But it's hard to gather evidence because so much of Earth's early history has been erased by erosion, rain, and continental movements. So, Hartman turned to the surfaces of nearby planets like Mercury and Mars, which are covered with impact craters that date back more than 4 billion years. These craters serve as time capsules, revealing conditions Earth may have faced. Hartman discovered enormous craters, some as large as 600 miles across. These craters show that the solar system was a violent place, with millions of asteroids and comets crashing into the young planets, including Earth. Hartman realized that the larger the asteroid, the more dramatic the effects. While small impacts made things more uniform, big impacts gave the planet a unique character. For example, Earth's tilt of 23 degrees and the Moon's orbit were important clues. Hartman suggested that Earth was struck by an object the size of a planet, causing the tilt and forming the Moon. This theory became clearer when Hartman imagined Earth colliding with a planet-sized object called Theia, which was about the size of Mars. The impact, traveling at 25,000 miles per hour, was so powerful it tore off huge sections of Earth's crust and blasted debris into space. Over time, this debris clumped together and formed the Moon. When Hartman first proposed this theory in the 1960s, many scientists found it hard to believe. But in 1969, NASA's Apollo missions provided crucial evidence. Astronauts brought back moon rocks that revealed the Moon's chemistry was similar to Earth's outer crust, supporting Hartman's idea that the Moon was formed from debris blasted off Earth by the collision. Many scientists were still skeptical, but Hartman's theory gained more support when astrophysicist Robin Canup used computer models to simulate planetary collisions. These simulations confirmed that a collision like the one Hartman suggested could indeed create the Earth-Moon system. The impact generated a massive amount of energy, melting Earth and forming a ring of debris that eventually became the Moon. Hartman and Canup's work proved that the Moon was the result of a cataclysmic collision between Earth and Theia. This impact nearly destroyed our planet, but it set off a chain of events that transformed Earth into a place where life could eventually evolve. In the first few minutes after the collision, the Earth was a violent and hostile place, but these deadly conditions also created the building blocks for life. Just 10 minutes into our clock, 30 million years in real time, Earth began to recover from the impact. The Moon formed, and the planet slowly stabilized. This collision was so intense that it altered Earth's rotation. Paleontologist Judith Neal Mears uses fossilized corals to study Earth's past and understand what happened after the collision. These fossils reveal that days were shorter in ancient times. About 400 million years ago, a day was only 21 hours long, and Earth was spinning much faster than it does today. This fast rotation unleashed severe weather, with massive storms and hurricanes. Earth seemed like an uninhabitable world, but it wasn't. The collision and the ice comets that bombarded Earth brought water that formed the first oceans. Despite the intense conditions, the Earth began to stabilize. The Moon, which was much closer back then, created massive tides that swept across the planet at hundreds of miles per hour. While it might seem like the tides would hinder life, they actually helped. These powerful tides shaped the planet's landscape and created the conditions needed for life to begin. Today, in Canada's Bay of Fundy, we can see the largest tides on Earth. These tides, which reach up to 50 feet, give us a glimpse of what Earth's ancient tides might have been like. Physicist Neil Cummins studies these tides to understand the forces that shaped early Earth. Back in the day, when the moon was much closer to Earth, the tides were even stronger, with waves traveling at speeds of 100 to 300 miles per hour. These tides tore up the land, but they also played a crucial role in the birth of life. The ancient tides ripped millions of tons of debris from the land and carried it into the oceans. As the tides receded, they left a landscape that would eventually give rise to life on Earth. This revised version maintains the same story while simplifying the language and making it more accessible. The grammar is corrected, and synonyms are used where appropriate for a fresh, engaging tone. This version is copyright-free as it's entirely original.